Hello, everyone. At linedevday, we are aiming to share our technical experiences with you developers so that Line can contribute to the industry growth. Today in this session, I would like to talk about how Line's infrastructure has been changing along with the growth of Line services, as well as what challenges we have moving forward. I hope that our experience in Line infrastructure can help you in your journey to tackle infrastructure-related challenges back in your workplace. I work for Line Infrastructure as an executive officer. My name is Younghee. Since 2013, I've been working as the head of the IT Service Center and supervising both domestic and global infrastructure-related organizations at Line. In the midst of living in the world with COVID-19, the importance of information technology and IT services is only increasing. Compared to the pre-COVID-19, many more IT services are being used, and along with that, the usage of IT infrastructure such as servers and network is surging rapidly. At Line, for big events like Christmas and New Year's, as well as any unexpected events like a natural disaster, our infrastructure is prepared to be durable, even with a threefold increase of traffic. Thankfully, the rapid traffic increase due to COVID-19 has been also well handled. However, we still decided to step back and consider whether our preparation was good enough and whether we can provide even better services. After its service launch in June 2011, the Line app achieved 20 million downloads in March 2012. By May 2013, 150 million people signed up for the app, and by April 2014, the number of the users increased to 400 million. You can see the significant growth in this graph, but from the engineer's perspective, the rapid growth of the service also meant that we were facing a serious need in handling the high volume of traffic. Since 2014 up until now, the number of monthly active users doubled in the four main markets for Line services, which are Japan, Taiwan, Thailand, and in Asia. Accordingly, we ramped up the Line infrastructure in large scale. Network by 6 times, CDN by 12 times, servers by 5 times, and storage by 4 times. We have 2 IDCs in Japan in addition to the ones in Singapore, the US, Germany, Korea, and Taiwan. The number of offices where Line employees work also increased by 3 times. As you can see, the Line infrastructure has increased its scale to cover the global regions in a short period of time as the Line services grew. Speed, global, and scale. These are the 3 keywords that constitute the DNA of the Line infrastructure. Now, let me talk about the challenges we faced in the initial phase of the Line app when we saw a significant rise in the traffic of the messaging app. During that time, every single day, the service was confronted with issues large and small. One of the challenges that we faced was the difficulty of understanding the current status of infrastructure. As you may have experienced before, there were many internal systems, and to access them, we needed to ask for access permission. The Line infrastructure also allowed only certain numbers to access many different services. So to get the information of the infrastructure, we had to contact the responsible departments or members via email, messengers, and other communication tools. When Line engineers find any issue in a service, they try to understand the current status by looking at these elements at the same time, as you can see on the slide. For example, they ask questions like, Is the database responding fast enough? Is there any query that is taking a long time to process? Is there any issue in network between IDCs? Is there any packet loss on a carrier network? As you can imagine, when a service has an issue, it would require a lot of time to understand whether the cause is actually in the infrastructure. The infrastructure team does handle such issues, but that would make them unable to work on other things until they finish. In addition, in such a situation, as the number of services and the complexity of the system increase, we would face issues more frequently. In response to this situation, we decided that as much infrastructure-related information as possible need to be open to all of the engineers involved in the service, instead of limiting the access for just a few select members. For all members to be able to search information of infrastructure without having to request access permission, we organized the information about systems, networks, and databases, and created a system where engineers can find the information that they need. The system is called IMC. IMC is the line infrastructure team's very first infrastructure system that is open to all engineers. This attempt to have transparency of information became the starting point of the collaboration between the infrastructure team and the development teams. When transparency becomes a norm in the organization, that leads to remove the information gap and enhance efficiency, and ultimately, the team will have more active communications. This comes down to one of the line developers' cultures: be open. The Line Messenger is not the only service that Line has. To evolve as a live photo platform, news, pay, live, music, and other various services started to be born concurrently. The more services Line has, the larger the development organization has become. Services have been rolled out globally, and development projects are progressing not only in Japan but also in overseas at the same time. In this approach, it was no longer possible to build infrastructure upon internal requests and deliver it in a few weeks to the development teams. So we started to question, to automate the manual work and to provide and manage the infrastructure more smoothly, what should we do? Luckily, when Line started to consider migrating to a cloud system in 2015, OpenStack was already mature enough to utilize, and the Line infrastructure team had gained confidence in development through the experience with IMC. Given the Line scale, using a public cloud was not an option from the cost perspective. At Line, it's common that a service's requirements constantly change, so we needed to prepare an infrastructure accordingly. To fundamentally solve the confronted issues through infrastructure service, we decided to develop Line's own private cloud. In 2015, when we started developing a private cloud, the Line infrastructure team did not have one single expert in cloud development. We tried as much as possible to reduce the areas to develop on our own and develop minimum features so that we can focus more on creating something that can help us reduce our workload. For the integration with internal systems, we only use SSO. With minimum level of customization of OpenStack, we kept the UI of OpenStack Horizon and first launched the features for VM and bare metal only. When it first launched, we used to call it just IaaS with no official name. But this IaaS was later reborn with the name Verda. We currently have about 60 members in the organization dedicated to the cloud service for its development and operation. Verda means green in Esperanto, Since this is Line's cloud, we decided to call it green, Verda. Currently, other than VMs and bare metal, we also provide many various components through this service. Regarding the scale, we operate over 55,000 virtual machines, over 20,000 physical machines, and over 2,000 hypervisors. This is the actual screen of Verda. You can see category components like project management, compute, network, database, contents delivery, media platform, CI/CD, code quality, monitoring, audit, and deployment. These are all offered on Verda. Here, while monitoring VM, you can select region and generate VM. Since Verda is used by all line engineers, we cared about the quality of UI as well. As you can see, even in the situation where we operate infrastructure focusing on speed, ensuring that the overall resources are utilized efficiently is one of the important roles of the infrastructure team. Now, let me introduce you to how we manage server resource utilization at Line.
First, about the 15% of our all server is the benchmark for utilization, which we define based on CPU, memory, file system, and network usage. This benchmark screens the 15% of our all servers, which we call low usage servers. Low usage servers might be required for temporary testing, redundancy purposes, minimum configurations, or they may be used for services in the future. In those cases, it is hard to do something immediate on them. However, some of the lower usage servers are not managed and can be returned. Lowering the specs down, replacing them with virtual machines, containerizing them could be options too. Also, configuration changes of applications can help returning these servers. In our case, usually 20 to 25% of the low usage servers are returned. The ratio of the low usage servers can go below 10%. In such a case, to keep the ratio at 15% again, we will raise the utilization benchmark. Here in Line, we have the cycle of step 1 to 3 for 3 times a year, resulting the improvement of our overall server utilization by around 10%. If any of you in the audience have similar challenges and haven't tried this yet, I encourage you to try as it is very effective. Now, the most critical part is how we handle the long remaining low usage servers. For these servers and applications operating on them, we will have to take on some technical challenges in the future, if not now. As our infrastructure has grown, the information on our infrastructure has become open internally, and the delivery and management have been automated. How do developers use infrastructure? What features do they need? These are the questions our infrastructure team had, and the team has discussed with our developers to deepen the understanding of the developers' needs. As a result, we think we still have the following challenges. How we go beyond the limit of resource utilization. When the server rooms in our data center needs renewal because of their age, whether our developers and our infrastructure team will need to spend 6 months on migration project. In Line's infrastructure, to enable programming by coding, we provide APIs for all of our features, but are they easy to use? Still, load balancers, CDN, DNS, ACL, and so on are the infrastructure technologies that the Line's developers have to understand. Whenever we have infrastructure work internally, our developers may have to work along with its schedule to move applications to another infrastructure, consuming their time. Developers can learn infrastructure technology. However, instead, if we can improve our infrastructure technology, then the technology might grow to understand developers' jobs and operate them. Then we can spend our time on more valuable areas. So here's what we aim at. On a data center scale and on the infrastructure with all resources available, without developers' interference, applications will be able to move between server rooms. Even without a good knowledge of infrastructure APIs, developers will be able to create infrastructure in a declarative manner. This is the infrastructure project that we launched. This project is called Plano, meaning flat in Spanish. As we are targeting a large-scale flat platform, we chose this name. Up until now, we have provided customized infrastructure for each applications. In this way, applications and infrastructure are closely coupled with less flexibility. Line has hundreds of services. Having infrastructure adjust with all applications would be difficult and inefficient. So, in Project Plano, as you can see, between applications and infrastructure, we will add the resource abstraction layer so that we can contain applications more efficiently. In addition, application deployment and a part of operation will be the expanded responsibility of our infrastructure team. So developers can use infrastructure without knowing resource abstraction well. Plano is estimated to take 3 years to achieve everything. Infrastructure orchestrator, CI/CD pipeline, resource scheduler are the examples of its various ongoing sub-projects. As for the project update, I'd like to bring you more at our next Dev Day. Let me have a sip of water here. Line service is recognized as a social communication infrastructure, so protection of personal information, service continuity, and contribution to the Internet society are some of the expected roles that we have to play. Among them, let me talk about our main focus area going forward: Business Continuity Plan, BCP, Disaster Recovery, DR, and IPv6. With our current line, even if one entire IDC can't operate, text messaging will not be stopped. Text messaging available for 24 hours. This is one of the standards to meet in our BCP and DR. To achieve this simple and clear goal, in Kansai region in Japan, we started constructing our second IDC in Japan. Kanto and Kansai regions in Japan are connected by a large-scale network with thousands of servers for DR. Also, to synchronize data in the active standby architecture, we have modified applications and started synchronizing data between IDCs. Among the systems centralized in the first IDC, necessary systems for failover such as SSL VPN, DNS, NTP, Kerberos, Jira, Wiki, Git are now active in the second IDC. In this way, failover steps were simplified, shortening the time. Also, the active-active method architecture is available in the messaging front. Here, usually it is connected with the first IDC, but when its configuration is changed, it will get connected with the message backend of the second IDC. What is the next thing we should do? In the second IDC, servers are on standby and the cost of them is concerning. The standby servers will handle data analysis tasks, which will see no problem when disrupted during the emergency. We spent 2 years on this project and completed in 2018. It was challenging, but I think we did quite well. However, the current DR needs more improvement. The message backend of the second IDC shifts from standby to active in failover, but this takes as long as 3 hours. Moreover, after the failover, failback to the original service state takes a long time. Failback may take several months. Once again, we are redefining the level of DR. That is, zero time or messaging. All the components consisting of line messaging will operate as active in multiple IDCs, and failback can be a short time. We are designing such an architecture. As you can see, Line as a social infrastructure is trying to achieve even more advanced BCP and DR. Achieving zero time or messaging will require some more time, but we will strive so we can share the updates at our Dev Day. Among domestic devices accessible to the Internet, 35 of them consume contents through IPv6. IPv6 devices are increasing rapidly. Line app in your smartphones support IPv6, but Line's server side supports IPv4. Through DNS64 and NAT64 technologies by mobile carriers, IPv6 devices can be connected with IPv4 service. The current scheme puts a heavy burden on carriers and involves more communication layers. So this is not a good tech architecture. The shift to IPv6 at the server side will align with the direction that the Internet is heading. So, since 2 years ago, Line proceeded the project to support IPv6 at the server side. From next year, 2021, we will support IPv6 at the server side. Please look forward to that. Together with the growth of Line's service, we went through some important milestones at our infrastructure, and I shared some of them today. I hope that our experiences will help your wonderful challenges ahead of you. This concludes my presentation. Thank you very much for your attention.